Okay, so this is a structures and properties video about ionic substances, and it is relevant for all of the AQA GCSE specs and probably lots of other exam specs as well. So, ionic substances. Ionic substances are arranged like this. So they've got alternating positive ions and negative ions in a lattice structure. So it's a giant structure of ions added to each other. We can see from this picture I've borrowed from an exam paper, it is not just a two-dimensional arrangement, it is in 3 dimensions. So although these ions are positive, negative, positive, etc., they also run in all dimensions. So positive ion here should be surrounded on all sides by negative ions, and it will just continue on and on for thousands of ions. So, in ionic substances, we have got metals and we've got non-metals. This is how you identify something as an ionic substance. If it contains a metal, such as potassium, and a non-metal, such as iodine, then you know it's going to be an ionic substance. Now, ionic substances, the metals are going to form the positive ions, because metals, I'll just sketch a periodic table here, metals are on the left hand side of the table, and this means it's easier for a metal here to lose 1 electron and go back round an upper row than it is for it to gain all the electrons to take it over to the right hand side column. So metals will always form positive ions. Non-metals, opposite deal, they will form negative ions because they're all over here, so they are closer to forming full outer shells by gaining electrons than by losing them. So, metals form positive ions and non-metals form negative ions. Now, in an ionic substance, we need to know how to describe the structure. So, we say it is made up of positive and negative ions. Excuse the abbreviations, don't use them yourself. Positive and negative ions arranged alternately in a giant lattice structure. So it's giant because it's got all of these ions going on in all directions forever. Remember, the edges of the diagram here wouldn't necessarily be the edges of the structure, so it will go on in all directions for a lot longer. It's a lattice because it's got this regular arrangement of ions, one after the other, and the structure speaks for itself. So it's made up of positive and negative ions arranged alternately in a giant lattice. Don't misspell lattice, by the way. It might be funny to write lattice, but will it get you the mark? Right. So with these positive and negative ions, they are held together by strong electrostatic forces between oppositely charged ions. And they absolutely love this phrase. This strong electrostatic forces, or attractions, let's put attractions in there, that's better. So strong electrostatic attractions between oppositely charged ions. They absolutely love this phrase because it's really descriptive and it shows that you know they are strong, they are attractions, and they exist between things with opposite charges. So just like in the old wives' tale, opposites attract, positive charges are attracted to negative charges and they will stick together. Right, The other thing you need to know about ionic substances are their properties. And you need to link them to their structure, generally. So, properties. First off, they've got really high melting points. Sorry, can't write. And boiling points. And this is because of these strong electrostatic attractions between oppositely charged ions. It holds them in place really strongly, and they don't melt very easily. Next up, they've got this peculiar conductivity property where they don't conduct electricity when solid, or in fact as a gas. Put that in brackets because gases don't conduct electricity. So they don't conduct when solid, and this is because the ions cannot move. Okay, so let's scrap that out. So they don't conduct electricity when solid because the ions can't move. Conduction of electricity generally can be done by two things: free ions or free electrons. If it's moving and it's got a charge, it can conduct electricity. Remember, electrons are negatively charged. Okay, so ionic things don't conduct electricity when solid because the ions are all stuck in this giant lattice structure, so they are not going anywhere, they're all jammed in there. But they will conduct if you melt them. So when they're liquid, they will conduct electricity, okay, because their ions can move. And they also like you to put in and carry charge. They'll also conduct, and it's also easier for them to do it this way, will conduct electricity in solution for exactly the same reason. If they are in solution, they are mixed up with water molecules, they are all moving around, and they can move and carry charge. On the solubility front, most ionic substances are soluble in water. Not all of them, some of them are insoluble, but most ionic substances are soluble in water. If you're given an exam question where you've got something that has a high melting and boiling point, it is soluble in water, then odds are it's going to be ionic, and you can talk about it in that way. Let's look at a couple of exam questions. So, here we've got sodium chloride is a typical ionic compound. It's got a very high melting point. Explain why, for 3 marks. So, first off, you're going to explain it's ionic, so it has alternating positive, not abbreviating because I'm doing an exam question, alternating positive and negative ions arranged in a lattice. They are held together. Changed from doing numbers now, so let's rub that out. They are held together by strong electrostatic forces of attraction between negatively charged ions. Oh, between oppositely charged ions. Okay, it's talking about melting point. When things melt, you need to break the forces within them. So, held together by strong electrostatic forces of attraction between oppositely charged ions. These need lots of energy, let's put in brackets, heat, to break and melt. And that should get us our 3 marks. Next one, explain why solid sodium chloride does not conduct electricity, but when molten it does. So this comes back to, that was not the right page, this one, comes back to this, ions moving. So if it's liquid or in solution, then it will move the ions around and they can conduct. So solid sodium chloride does not. Solid, so shorthand, solid NaCl has ions that are fixed in place and cannot move or carry charge. So that explains why solid sodium chloride does not conduct electricity, but when molten it does. When it melts, the ions are able to move around and carry charge. And that should be our 3 marks, because we've got solid has ions that are fixed, cannot move. When it melts, they can move, and we've got the carry charge key term in there. They love things that can carry charge. Okay, so if you get 2 marks for conducting electricity, it's because something can move and carry charge. Okay, that was an overview of ionic things and some exam questions, and please join me again for the next type of structure.